Hello, so today I'm gonna use improper integral. So in this integral, everything's fine except for this infinity. Because you can't put infinity as an interval, one of the interval, you have to change the whole form so we can actually integrate them. So we can change the whole thing into limit b goes to infinity, 0, b, and the equation. So here, because we're not allowed to put infinity for the interval, I changed the infinity sign to b and took limit when b goes to infinity. So actually this means the same thing as this, but we change into this form so we can actually integrate following the rules. So after taking limit, it's just all easy. So take that down here, limit b goes to infinity, and all we have to do is just use our knowledge of integration and actually integrating this, which is this right here, and then you can change that again, just simplifying this. Now it's easy. According to the fundamental theorem of integration, we can rewrite the whole thing into b plus 2 to the 1 minus, it's now substituting the bottom part, which makes it plus 0 plus 2. So now here you can conclude as this. Then now we just have to put limit. So because b goes to infinity, this will be infinity plus 2. So now the infinity plus 2 times 2, that all makes it into infinity. So which will make it like this. And when infinity is in the bottom, this goes to 0, so it will be 0 plus 1/4, which will equal 1/4. Now this was one of the basic problems of improper integral, and in the book I found really interesting question, which is 36 of chapter 7.7. So the question is asking us to integrate this. So this right here looks very ugly. I don't even know how to integrate that, but the book kindly says that d dx sine x over x equals the highlighted part. So this means the derivative, so we can rewrite that into integral derivative of sine x over x. So as we know, integration is the opposite of derivative, differentiation. So this will just equal, this will equal sine x over x pi from 0 to pi, because the integral sign and derivative sign, they just cancel out, so they just end up like in this form. So here now it's easy. So from here we can just rewrite that into sine pi over pi minus sine 0 over 0. So now here, this right here is very easy. It's just constant. Now actually sine pi goes to 0, so the first term here will end up being 0, but sine 0 over 0, this is 0 over 0, which is indefinite form. So actually we can take the L'Hopital's rule and make it into cosine x over the derivative of x, which is 1, so it ends up being cosine x. So you can say that sine pi over pi minus, which was this, substituted by 0, we rewrote it as sine pi over pi minus cosine x, and then substitute 0. So this ends up being 0 minus cosine 0, which is 0 minus 1, becoming negative 1. Thank you.